My name's Sebastian. Welcome to another episode of the 3D Show. This episode, we're talking about as-built and as-design, and how do we bring as-design concepts into the as-built reality? How do we leverage that with knowledge of the point cloud, and more importantly, how do we leverage the technology of different sensors in the market into bringing this to an as-designed workflow and workspace? And how does it help you, the architect, engineering, construction, and operation and maintenance organizations? My name's Sebastian. Welcome to another episode of the 3D Show. I'll see you super soon. Back to the attic, everyone. Peace. Well, just looking at the plans, they're not as built, but that's why we're scanning, aren't we? Right? What is up, everyone? My name's Sebastian. Welcome to another episode of the 3D Show. And in this episode, it's a little bit lighter today, so hopefully the sun does not block my face. But hopefully you're going to get the whole purpose of this episode. We're talking about as design and as built and how do they merge together into the world of AEC, and most importantly, leveraging that reality capture technology or the point cloud. Now, before we even start, I just want to quickly define what an as built is and what is an as design model. As design refers to the initial set of drawings and specifications created by the architect, engineer, and designers before the construction begins. These documents represent the design's intent, outlining the plan dimensions, materials, and features of the project. So to bring this into context, if an architect gives you a BIM model or a 3D model of the conception of the site, taking certain things into consideration, whether that's the surveying coordinates, looking at the constraints in some aspects of the dimensions, they're giving you an as design conception. So remember, as designed is not always meaning as built, but let's define as built. As built refers to the final set of drawings and documentation that reflects the actual construction of the project. These records include any modification, deviation, or changes that occur during the construction progress. The as-built documentation provides an accurate representation of the complete structure, capturing all adjustments made from the original as-designed plans. Now, let's really talk about how the technology can help you get to that world of as-built and as-designed into one single world and one single coordinate system. To start with, reality check. It's the aspect of what a lot of people in the 3D laser scanning and reality capture space do. They ask you, what are your as-built or what are your current CAD models, DWGs, RVTs, Navisworks files? What is your current 3D model and what is the reality here? So we do certain types of corrections. So we take the 3D model that they have and then we look at the point cloud data and we see if it's to scan. If they don't even have that, then you create a scan-to-BIM process, meaning that you start from zero. You scan, you might have a template from the client and then you bring that and import that with the template and you make an as-built drawing. But what happens if they already have a model? A lot of times when I'm on site with an architect and they say, hey, I need to make this as-built, I say, give me your current model. And they're a bit apprehensive at first. They ask me what's going on. And I tell them, well, I'm taking your current model and I add the point cloud, and instead of me doing things from scratch, which also reduces cost for them, I'm taking the things you already have and existed and I'm aligning it based on the as-built realities. That's going to help them then communicate with the construction team or the engineers in order to either create that as designed as it should be, and or to modify and to generate their as-built drawings as they are intended based on the as-designed conception. Now let's give you a specific quote here and some statistics. A recent study found that projects that use reality capture to validate as-built conditions against the as-designed plan saw a 30% reduction in project overrun and rework. What does that really mean though? Well, it means that if I'm able to look at the as-designed model and I'm able to look at the as-built information, what I'm able to do is I'm able to see if there's anything that's going on the site during the site's operations. Now you have to do that really quickly. You have to be able to scan, take a terrestrial laser scanner, a mobile scanner, photogrammetry, any kind of data set, and you have to bring that into your current model and then you have to merge that together. That way you're going to be able to maximize both their work and your work, and you're able to reduce downtime. The whole purpose of scanning when it comes to construction, because that's why things are so fast, is you want to be able to make the corrections on the spot before they have to do any kind of rework, because rework or revamping certain things is going to cost a lot of time and a lot of money. The second interesting thing here is the digital threads from the design's dream to the reality of the scene. Now, I'm being a little bit poetic here, but I'm just trying to get a little bit more mellow on how we want to bring this up. What's going on today is that designing companies and particularly architectural firms are becoming more and more regulated. In order for you to qualify into being an architectural firm in North America, in Canada, and or United States, you need to go through more and more paperwork. As the boutique market starts elevating and as it becomes more and more numerous humorous that there is a growing inequality in the world, these boutique markets also have architects that are going to become more and more strict because there's higher budgets. If I'm presenting a project to a bunch of investors, I need to show them that whatever I have as a concept and whatever you paid for is going to translate to the reality. As design is the design of the client's needs, as built is the reality. If we merge that together, that becomes a massive value proposition for any kind of shareholder, stakeholder, AECO company. Why did I bring up digital threads? Well, digital threads are like a repository. If you have a thread of what's going on in the construction site and you align that with the reality capture point cloud data, thread allows you to have that repository. It allows you to see what's going on in each phase. That's going to help you in two aspects, the construction progress management side, and then the alignment with the construction team and the engineering team and the architectural team. So that means that all three stakeholders are aligned for them to get that project done. Projects that maintain continuous digital threads report a 25% improvement in coordination efficiency and 20% reduction in delays. Well, the third part is digital magic. Now, what does really digital magic mean? Bringing designs to life from the 3D to reality. If I have to do a retrofit or a revamp, I'm going to have my suggestions of my engineering team. So I take the as designed, the suggestions from the engineering team, and the as built, and I merge them together, and now I can actually give a very, very clear picture of the project timeline. How much work does it need? What areas of the site need to be shut down or closed off? In order for us to have that connective tissue, you need to have the design concept available. You need to have the point cloud data and or point cloud scan-to-BIM model available that you merge them together. And then you need to have that final workflow phase. Number 4, adapt or die. Flexibility in the face of change. Once I have the as design and I have the as built, then I can sit down with the proper people and say, well, this doesn't work. What can we do as an alternative? Construction, nothing goes according to plan. But if you have the understanding of your constraints and you have your as designed concept model, you can be the closest to what you actually wanted. And true creativity always comes with limitation. When you have the true limitations, when you have the actual millimetric information of the site, I've seen engineers do magic with the data we've had. But in order for them to do magic, they need to know how to handle the data. Everyone is trying to work for a single goal of getting the job done and understanding that we can't always do it the way they want it, or we can't always do it the way that they're looking for. But the point cloud becomes that understanding saying, hey, it's not me, it's the site. It's not me, it's the reality. It's not me, it's the data. Anyways, hopefully it made sense that reality capture becomes a pivotal tool for as builds and as designs and some of that ethereal information I gave you, but most importantly, it helps us at our construction progress management workflows. It helps us with our engineering stakeholders, our architectural design teams that make the as design models, and our construction team workers. And it helps us align that with maybe those investors that we always have to deal with. I'm super excited to go to that next part, which I want to talk about, which is facility management. And my name's Sebastian. Welcome to another episode of the 3D Show. I'm going to see you super, super soon. See you everyone. Ciao, ciao.